Hello and welcome to episode 16. Episode 15. Don't want to get ahead of ourselves. It's episode 15. It is my great pleasure today to welcome back Amplified. I'll introduce our panelists in just a second. A little bit of housekeeping. Many of you have been with us before, so you know about the control panel. You'll notice in the control panel, there's a section for handouts. There's a couple of handouts there that you can go ahead and grab. There's also a section for questions. And so please, whenever you think of a question, go ahead and put it into that section of the control panel, and I will be monitoring those throughout. As I see an opportunity to interject with our panelists, I'll go ahead and stop them midstream and ask them those questions. So please don't be shy. Ask as many questions as you like at any point that you like during the presentation. There is also going to be an email sent to you tomorrow with the recording. So you can go back and look at this as often as you like. You don't even need to provide an email address after this one. The link that you'll receive in the email is specific to you and your email address. I don't know if people actually know that, but if you forward that link, it won't work for other people because the email, the link is tied to your email address. And finally, there is a short survey at the end. Please, as you're departing from the webinar, go ahead and take just a minute to answer a couple of questions. You'll really help myself out as the organizer, but also the presenters. If there's questions that we didn't get to, that you didn't have a chance to ask, that all of a sudden, the second we signed off, like, oh, darn it, I forgot to ask this question. You can still do that. And again, this is episode 15 featuring Amplified. My name is Tony Trippi. I'm founder of ML4Patents.com. Managing Director of Patent Informatics, although I don't do all that much of that anymore. IP Manager at Owens Corning, and I'm joined today by Sam Davis and Yasu Oikawa from Amplify. And with that, I will hand this over to Sam to go ahead and get us started.
Thanks so much, Tony, and really happy to be here. I'll get straight into it, get my screen shared. What I wanted to kind of open up with to talk about today generally is an update on some new features in the Amplified platform and share some case studies that we've been a part of for evaluating the performance of some of the AI tools that we've built. And then after that, we'll get into some case studies to share how some of our Japanese customers are using these tools in their processes. Over the past couple of years, we've gone from really doing a lot of pilots to much more active kind of full-on deployments into day-to-day workflows and processes, and it's just been a really fascinating journey working alongside a lot of different companies around the world. But wanted to take today as an opportunity to share a little bit of what happens in Japan, because that's often not something that I think gets a lot of exposure internationally, and maybe helpful and interesting to see. So for that portion, I'll turn it over to Yasu to talk about that, and looking forward to answering questions as we go. So getting started here, talking a little bit about kind of integrating AI and machine learning tools into modern IP practice. I want to step back from that for a moment and sort of think about the goals. What we want to achieve with AI is that, at least in theory, machine learning should make our work more efficient. It should allow tools to be easier to learn so that there's more access to it, so that a greater number of people can benefit from patent information, and it should enable us to get higher quality. So we should actually not just be seeking to replicate the same kind of quality that we're able to get today, but actually AI tools should allow us to go beyond that and do better. In order for that to happen, it really depends on a few key questions, and I want to share this as what we really have focused on with how we build Amplified and the key kind of challenges that we're trying to overcome. So first, is it reliable? And this reliability question really drives everything related to productivity and the efficiency gains that we want to realize. The next thing is it explainable? And this kind of boils down really to reproducibility. At the end of the day, AI is not and never will be fully explainable. I probably shouldn't be quoted on that because I never say never. but it's very hard to explain really at a detailed level to a large number of people how even a simple keyword search works under the hood, much less AI. So what it's really more about is reproducibility. Can we reproduce things such that we can observe and understand and learn? When I pull this lever, I get this reaction. And if we can do that, then we can work with the tools and we can develop processes. And finally, is it controllable? And this has to do with flexibility. The patent world is not a world of absolutes. Everything is subjective, very much contextual. And so we need to have the ability to work with machine learning tools that can adapt and can be flexible and change as the situation demands it. So these are the three kind of core things that we try to tackle. Starting with the first one, reliability, I have to come clean and say that this is really, really hard. And there are a whole bunch of different reasons why, without getting into all of them. One of the biggest, and this, I think may resonate with a lot of you who may have tried different, machine learning or AI tools over the years, whether it's something, more old fashioned, like a kind of a scoring statistical type of an algorithm, or looking more at something advanced, like, deep learning based classification. Reliability is just really hard because there's a ton of data. Patent data is both very, very big data, but it's also very sparse and small data. And this chart here shows 1.5 million PCT applications and the distribution over technology areas. So if you split them and look at the volume over 664 CPC subclasses, you can see that some fields have a lot of applications and some have very few, which, that's not news to any of us. But from a machine learning perspective, that means that you have just an overwhelming amount of data in certain areas and very little in others, which makes it extremely difficult to teach an AI to learn something that generalizes, that works well across technology fields. And so that's a major, major challenge. And I'm going to devote a little bit of time to kind of talking about that now. And the relation that the reliability has to productivity is really important. And in particular, there have been a number of very interesting studies kind of comparing different AI tools and traditional tools. One that kind of caught my eye was one by Riahi IP. And what really caught my eye about it is, and why I think it's kind of interesting to look at, is the way that they designed the study is a little bit unique in that they don't just look at the initial raw results from an AI tool. They actually allocate equal time to a traditional method as well as an AI method. And this is helpful to give us a productivity baseline, because if we basically think of a search as the amount of time you spend times how productive you can be, per hour, and that yields your ultimate quality outcome. Well, if we hold time constant and we measure quality, then we can kind of back into what is the productivity, and that's a good way to compare different tools, I think. So what this study that they put together did was looked at traditional Boolean-based searching, and then two different AI tools, and finally amplified. And these are I know what the other AI tools are. We don't want to, share that here, but I can say that I have a lot of respect for both of them. They're very good tools. I wouldn't say that about every AI tool necessarily, but these are quite good AI tools. So it's a really good batch for comparison purposes. And what they did was took equal amount of time, and each analyst got a different tool, and then they were basically asked to see if they could find the best possible results in that amount of time, report them back, and then the results computed a normalized score based on the total number of relevant patents found in the features, total number of features within that. So in the first thing here, we just have a quick kind of sparkline analysis to make it easy to visualize, but the red shows the worst of the tools results. The blue is kind of in the middle, and we'll see gold for the best. So the traditional only search actually didn't get the best results in any of the cases, and in fact did the worst in 4 out of the 7, and was kind of middle of the road for 3 out of 7. So immediately this is a little bit surprising, actually, that it turns out that the AI tools already, they can definitely increase quality. beyond what was possible just through a purely Boolean search. But then the issue we get into is the one of reliability. And we can look here at AI tool B and C, and it's pretty challenging to think about how you might use these in practice. AI tool B didn't get the best in any of the 7, but they actually were pretty reliable. They got middle of the road results for 6 out of 7 cases. They were better than the traditional only in a couple, but they were actually worse in 1. And then by comparison, AI tool C, which is built on some newer, more cutting edge technology, did much better in 2 cases. They had the best results of all, but did the worst in 3 and middle in only 2. So much less reliable performance. And this is where the kind of conundrum comes in of, so if you're looking at this and you're thinking about tools to adopt, which one are you going to pick? Are you going to stick with traditional only? Are you going to switch and only use one of these 2 AI tools? Are you going to use all 3, or would you use a combination of maybe tool C and the traditional? There are a lot of different things to consider, and it makes it pretty complicated, because when you add tools, you reduce productivity. You have to learn more tools. It takes more time. Syncing data and trying to work between tools is both mentally draining as well as time consuming. So it's a kind of a complicated calculus. And this, in my view, has been why we've had relatively slow adoption of AI tools until pretty recently, because for a long time we've had different kind of semantic type search tools, but they all sort of ran into this reliability conundrum that made it really hard to actually deploy those tools into day-to-day kind of reliable, consistent process. And I was very excited to see the results for Amplified, that we were able to get the best results in all 7 cases. We tied with tool C on 2 of the cases. And that level of reliability is, I think, a complete game changer. It makes entirely new levels of both productivity and quality possible. The really exciting thing here is that it means that the kind of instant, quick results for just an immediate kind of a search are very useful and accurate. But then beyond that, every additional hour that you invest into searching, you're going to get the best ROI on that. That's the best results, kind of bang for your buck, that you'll get for additional time spent. And that generalizes really well across all of these different cases was, I have to admit, beyond our expectation and very exciting to see. Now, this is just one case study. There are only 7 cases here. So what about at kind of scale across other technologies? And in this, we've done some internal studies, and what we saw in the,
Yeah, I'd like to go back for just a second, because this is really fascinating. And granted, it clearly you want to talk about this because you guys did very well, and that's great. I mean, that's exciting. I couldn't agree with you more. It's outstanding validation for a lot of hard work over the years. But I do want to make sure that everybody, including myself, understands that this isn't F scores. This is not a precision versus recall. And so if you wouldn't mind, just again very briefly walking through the productivity measurement that we're talking about here, because I think you've got a great point also, that and again, even in some of my own experience, a big part of what is going to bring these tools up and over the hump, or over the barrier of activation that we're currently seeing, is how useful, valuable, and time, how much time you save, how efficient. So I think everybody can recognize, well, okay, maybe if as long as I get a little bit like Google, you don't have to find the answer. You just have to find some good answers, and you have to be able to find them quickly and efficiently. And if you get enough answers, enough data, enough knowledge to then move on, that's the point. The point is not, again, the hardcore patentability and freedom to operate and people that are concerned with needles and haystacks. that's not what we're talking about here. It has never really been what we've been talking about for a variety of different topics. That's very precise and very, it's a very different type of search. But most end users, most of the people that you're working with are going to want to be able to sit down quickly and easily put together a query, fire it off, maybe make some improvements, making slight tweaks, and then be able to evaluate those results quickly, and then they're off. They're on to the next thing, the next item on the to-do list. So yeah, if you wouldn't mind, I'm personally quite interested in this measure, and I think since it's something new to the group, other people might like to hear just a tiny bit more about this idea of determining quality and return on investment.
Yeah, yeah, no, and you're exactly right. This is what's really challenging and unique about prior art search in particular is, how do we think about measuring it? So, really from day one of Amplified, I've always held that F1 scores are great for classification. They're not so great for prior art search, because whether you're trying to find everything possible or you're just trying to get a quick idea, that F1 score doesn't really help you understand that the ROI there. Because in theory, a prior art search can just go on forever. You just keep searching and you may or may not find something new. And until you've searched and read every single patent, you won't know with 100% certainty that there's not something else out there. And that's even just, within the world of patents. There's also obviously, non-patent literature and things that you would search outside of patents. So it's impossible to truly know. And so we need a better way to understand the ROI. And there are sort of two different sides to it. One side is what you explained with the needles in the haystacks. The people that it's not like a Google search, that they want to try to find everything under the sun, and they're really looking to maximize the recall. They don't want to miss anything, right? And that's sort of the one extreme. The other extreme is the person who, I don't need to know everything. I just want to be fast. It's all about speed. I want to avoid wasting time on irrelevant results, and I want to spend as little time as possible getting as much valuable, insightful information so I can just move on to the next thing. And we can kind of look at both of those. This study really goes more towards the former, about how can you get to that level of comprehensiveness. If we want to look more at the speed, I think it's just really, in that case, it's sort of like time to good enough. It's really hard to define good enough and come up with a metric to do that. Anecdotally, I know from our customers that it's generally in the range of 15 to about 45 minutes is usually good enough for most of the people that are doing that kind of a quicker version of a search. That's going to be a really tough thing to measure, I think, and compare. What's exciting to me about this productivity baseline, and I'll explain it again here, is that what we want to accomplish with Amplified is giving you that full spectrum, from the person who wants to jump in and, let's say they're at an early idea stage, they just want to get a quick idea, quick understanding, give them that value very, very fast. But as the process goes further, and maybe one day that turns into an invention disclosure, it becomes a patent filing, and you need to do a more robust search. What we're able to show now, and what we're seeing, and Yasu will talk about this later with some of the case studies, is that you can do that whole process now in Amplified, from the first quick search all the way up through the more comprehensive one. And that's where this productivity quality measurement, I think, is very useful. So the time times productivity equals quality thing, this is based on not an F1 score, but a score of just how many features were found. So without getting into too much of the details, it's something like, I think, 8 to 11 features per kind of case, and done in a very traditional, full kind of a search way, where the analyst goes in, makes for the traditional side, a fairly complex keyword strategy, goes and reads everything, and then reports the best results that they can find. And those results, will read on however many features. So they may find a patent that reads on all 11 features, kind of like X-reference style thing, or it may be, one that reads on only 7 of the 11 features. And then based on how many features got covered, that turns into a normalized score. So it gives you an idea of kind of the quality of the search. Given the same amount of time with different tool sets, what were the best possible results that this person could find, and how can we then compare across each of those to see, okay, given equal time, what did we find? What did we get the best of? And that's where we then get to these final normalized scores, where you can see that what it essentially tells us is for any amount of time given, the highest ROI you get back is going to be from amplified. And when I show some of the product features later, I think it'll become kind of obvious why that's the case. But a lot of it has to do with just designing amplified in a way that gives you kind of the benefits of some of the traditional search alongside some of the AI in one place. And so we're able to kind of get the best of both worlds.
One quick follow-up question. Somebody asked how much time was allowed. Since you keep mentioning the amount of time and that was held constant, can you share?
That is a great question. I don't actually know, and I'm not sure if I'm allowed to share. I do know that this is still a preliminary study. There are a total of, I think, 10 cases, and I know that REIIP wants to publish those a little down the road, so I don't want to steal their thunder. But from what I've understood, from what they've shared with me, they're pretty open about the methodology, open to sharing it, both for the benefit of everyone else, but also, to welcome any kind of constructive criticism or feedback about, how it could be made better. So I think all that will probably be made public. But it's a significant amount of time, from what I understand, just kind of anecdotally hearing it. It's not like a 1 hour or a 2 hour. It's probably somewhere higher up in the range of like anywhere from, I would imagine, probably 8 to like 14 hours, something like that, but I don't know the exact number.
Great, thanks very much.
Yeah. So kind of speaking to this and thinking a little bit about scale, and this will address some of the other questions about measuring the quality. Is we've done some of our own testing to get a sense of how it performs at scale. So coming back to our plot of data distribution with all of these PCT applications. So these 1.45 million PCT applications spread over all these technology areas cover about 4.5 million total examiner cited, international search report cited references. And we've done a very large scale benchmark study on that, just to look at, out of those 4.5 million ISR cited X or Y references, how many of those are we picking up in our first result set? So over here on the left, this first click, that represents Amplified's top 20. We show 20 results at a time on a page. So to get a sense of how quickly could you get something of an X or Y kind of level of similarity, 25% of those 4.5 million, you're going to pick that up basically right away, instantly. And this is based on using the specification of the application as the input. And then we've also taken a look at, with some iteration, with a little bit of human feedback, by providing a filter, how does that impact the results? And that number goes way up to 75% once you start looking within a particular filter. And so that's where you get this benefit of the machine intelligence on the left side gets you a good chunk of the way there instantly, but just a small bit of guidance from a human who knows what they're doing brings you up quite a bit very, very, very quickly. And we also then take this and we break it down to look across technologies, which is, coming back to that reliability question, super important. So all of those 664 subclasses, we broke out the ISRs by each and kind of took some averages of what we were finding and then looked at the standard deviation. And so you can see that it is not identical across technologies. There is some variation. You can see, especially in some of these chemical areas, which are kind of harder for a human to search as well, the results go down a little bit. And in some other areas, they seem to be disproportionately effective, but it's a relatively small standard deviation. And that kind of jives with what we saw in the REIIP study and what we've seen with our customers, is that the technology does generally work well across fields with some very, very specific kind of exceptions that we found, just working with customers that are not so much technology specific, but almost more business unit specific that we've run into. So, that's a bit of an update on some of the search sort of measurements that we've done to understand more about how the technology works. I want to take a moment now to actually show a bit about the product, some of the new features, and give you a sense of how the interactivity works, because that's the sort of UI UX side is almost as important, if not more important, than the AI side. And so, before I jump into the product to show that, to do a kind of a bit of a demo, at a high level, the approach that we have taken to designing the system is a combination of sorting and filtering. And again, this is not for classification. I'll get to that later. This is just for prior art search. So prior art search, when you generally don't have much, if any, training data and you're starting from just some raw text, what we do is we use the AI side purely to sort. So whatever you put in, we'll use that input to sort the entire database. There is nothing being cut out or excluded behind the scenes. That's really critical to making sure that it is reproducible and transparent to you as a user. And then the human is defining what to cut out, what to filter. So we start with that sorting. That's the one click I mentioned before. And then the filter, that's the second click. That's where the human comes in. And this becomes a very iterative process. And this is where we get the reproducibility and the flexibility that I mentioned at the beginning. So I'm going to jump over now to the Amplified app, give you a quick demo of a couple features and a little bit about how the interactivity works. So this is what an Amplified project looks like. And you can see here we have sorting and we have filtering. So those are the two main tools that we use. And then in the middle, we've got results. So these are the patent results. And I've got some loaded up already based on a very, very short description. You could put very long text in here, there's no limit, but a very short description. So what's happening right now is it's taking this short description and it's just saying, whole database sorted, here's what's the most similar in order to your text, and just displaying that one by one. And this on its own, you can just kind of see this is a toothbrush. It's about promoting good brushing habits. So it measures time per tooth. And it does this with a temperature sensor, detects the position of the teeth, measures the time. Pretty simple concept there, but you can see that we're getting a lot of results that are definitely in the right area. And you need, they're close enough that you actually need to spend some time reading a little bit more to really evaluate if they're directly relevant or not. So this is where the kind of filtering part comes in. Before I even get to doing any filtering, we want to understand what has the AI kind of found, how is it thinking about the results. And so I'm going to add some keywords here initially just to highlight the content. And these highlights, I want to think about this not from the perspective of searching. So I'm not thinking of keywords for search. I'm really thinking of it more from just ease of reviewing. I just want to make this fast and easy for myself to determine, are these results actually relevant? And so from that perspective, I know that I care about detection. So I'm going to put in detect as one word. I'm going to put in temperature, because this is a temperature sensor. So I don't want to see just any old kind of sensor. And I care about measuring time. So those are the things that I'm skimming for already. And you can see when I do this that instantly we get in real time these updates on keyword counts. So we can immediately see how many keywords are present for each result. But then I can also turn on, the abstract, and I could see the actual highlights of where these show up. Or I could go and do this keywords, which is a new feature we've added that will find where these keywords are showing up in the text and show them to you. And so I'm going to use this to kind of very quickly take a look. And before even really reading too much, kind of the first thing that I'm going to do is just scan to get a sense of what is covered in these top 20 results. And I can see all of my keywords appear to be present in result 1, result 2, result 3 has nothing. And as I kind of keep scrolling, what I find is I generally have detect and I generally have time, but I'm not seeing temperature. A lot of these results, I'm not seeing any counts of temperature. And so it seems like the AI has done a good job of understanding it's about detection. It clearly knows it's about a toothbrush, and it's got the time part, but it's not focusing on that temperature sensor. And this is where that human intelligence comes in. So I can see this and I can now make that decision. I'm gonna actually turn all these to highlight only, and I'm gonna be super specific and just say, I wanna see results that have temperature in the claims. I'm gonna turn on filter and update. And when I do this, that's what gives me that sort of feedback mechanism. So I've now kind of told the AI, not even really AI, it's just a keyword search. I've said, just limit things to claims that have temperature. And you'll immediately then see still sorted results showing up. And because the AI is doing a very good job of that sorting, and I've limited now within temperature, the results that you get here are really, really effective. Most of the time, this is kind of enough for like a first search pass. You'll get, just from looking at this, good enough information that you can kind of move on. For people that want to go kind of another step or do some more exploration, there are a few more things you can save what you find here, mark things as relevant, and then use those to kind of retrain the system. That's going to be really powerful if you save some things and turn filters off. So for those of you who are worried, and you might be thinking, hey, well, what if there's a different, what if they don't use the word temperature? You've missed things, right? This is where we get to that idea of being more comprehensive. You can expand your search, you can turn those filters back off, but benefit from what you've taught the AI and have it kind of update as you go and be very iterative in working through this. But you can also kind of explore things a little bit differently. So as you're working through the results, and I'm looking here and I'm seeing, I'm seeing what's highlighted with detected, detecting time, temperature. I may come across something that sort of makes me think, oh, maybe I should look for a different word. What if it's not just temperature, but what if I wanted to see, like, maybe there's an optical sensor? I can add that keyword, and again, in real time, it's going to update, show me the keyword count. If there are those keywords present, it will also update automatically the section within the patent. So this is pretty powerful. Instead of having to open, the full text and read everything, I can just immediately kind of query that full text and scan through all of my results to see, is the word optical showing up? And if it is, then in what case? So for example, for this, it says optical key. That's not at all what I was expecting. I was looking for optical sensors. Optical key is very different, but now I'm kind of aware that might be something that is present in these inventions, and I can think about that. So there's this kind of feedback loop between you and the machine that helps hopefully both the machine get some training data to learn more, but also you, the user, to get some additional data points that help you then learn more so you can work with it. And this is what allows that very, very high level of productivity. So those are some new features that we have in Amplified. Some other things to mention that are pretty important related to reproduce. Yeah, go ahead.
Quick question. This is coming from me, not from the audience.
Sure.
I'm going to assume that optical, because it was filter, didn't actually, and it wasn't used in the description. So it's not used in the sentence essentially that you used. Would it have made a difference? I mean, should you have then theoretically, would it have changed the body of patents that you're working with as far as then what is subsequently filtered if optical had been added to the initial description and then rejiggered?
Yeah, that's a good question. So what I've done right now, you can see the update results button is lighting up in red. That means that there's new kind of information that would change my search results. So currently, these results have not been filtered with optical. It's just populating and doing the highlight. If I click update results, it would then apply this filter and we would get a different result set. Similarly, if I made a change to my invention description, it will resort as well. So if I went back and I actually decided to change this and say, instead of a temperature sensor, I could replace that with optical sensor, that would change the results as well.
Yeah, and that's really critical. I mean, with so much of traditional searching being based on iterative design and learning from what it is that you find, and then creating another subsequent query and so on. It's the exact workflow that you were going through. The ability to have two different places where you can do that. Well, if you don't want to change the description because you don't want to really get into that, but if you want to update the results like you're doing there, as opposed to just highlighting the results, that's how you do it. So, all right, fantastic. Thank you.
Yeah, exactly. So this is, I haven't tried this before, so I don't know what it's going to look like, but changing this to optical, and then we can kind of see here the results that we get. And they're going to be sorted differently. So again, the text part is just the sorting, but then we could go in and we could be very specific. Looking at this, unsurprisingly, it didn't pick up that it's a temperature sensor. Doesn't seem like it's particularly concerned that it's an optical one either, but we do see optical showing up in some of these top results. And I'm sure if I click on claims here and I did apply this filter, that we would then get a completely different set of results from what we had before, because it's going to only be showing things that have optical in the claims. And you can kind of see here now that we're doing that, instead of optical key, we're getting a very different kind of use of the word optical. And that's kind of teaching us a little bit about, what's in this space. So it's very flexible in terms of allowing you to explore from different perspectives as you kind of learn and develop, and whatever the needs, whether the inventions changed or sort of the business needs change, you can adjust as you go.
Great, thanks so much.
Yeah, so the other thing I was going to mention here in terms of reproducibility is another really important part of this whole exercise is often we need to be able to explain to other people how we found something, sometimes more for a kind of a firmer kind of a legal reason, but often just because that's part of how we kind of are communicating with each other to learn and understand and explore more fully. So making sure that results are reproducible is really important. And we've added recently a feature called search history, which anyone who's done patent searching obviously knows search history is a thing. But what's kind of special about this is it's designed to work with AI tools. So it not only will track the filters that you've applied, and it will let you know which results you saved as relevant, how many you've read, so you can kind of know for any particular iteration what results did you work through, but it's also going to allow you to see how you sorted things, and you can use that to go back and reproduce. Right now, it's just a downloadable feature, so you'd have to go and kind of cut and paste to get back to the same previous query. But the expansion that we're working on now is something where you'd actually just be able to open up your version history, go back to a previous version of the project, and kind of instantly reload that. So, let's say you're working through here, you start saving things, you start adding a bunch of filters, and you start going off the path a bit, and you want to get back to where you were earlier. It'd be really easy to just open up your version history and kind of go pick a point and then reproduce from that and get back to that. So that's another feature we're very excited about.
I did get another question that's right along those lines, that this one coming from one of the attendees. How would you ensure that references already reviewed do not show up again once we iterate and change the filters? So it's probably more about the iteration, and when you update the results based on the use of the filters, how is it that you'd then be able to identify, well, I saw this one, in the last iteration of it, this one is now rising, or I haven't actually examined it yet, but it got a higher priority because of the reshuffling.
Yeah, that's a great question, and that's where these buttons are really important. Even if if you save something as relevant, it's helpful because you can retrain the AI. But even if you're not going to retrain the AI, when you read a result, it's really helpful to click on one of these, because that will keep track. So let's say I'm going through here, this is relevant, this one I'm not sure, so I flag it. This one is relevant, and maybe this one is not relevant, so I hide it. If I'm doing that, it's going to keep track, and I can kind of customize whether I want to show these in my results or hide them, so I don't have to see them anymore. And that's going to be super helpful as you iterate, because let's say you've reviewed 20 patents. You don't necessarily want to see all of those popping up again. You can just hide them, and you can turn them back on later as you iterate. And that'll give you an idea, like, have I seen this before, or is this brand new? And it'll keep track. The other thing is we also actually do this across projects as kind of like a private knowledge base. So you'll see this icon for notes in some cases lights up in gold. When it lights up in gold, it's actually because I've seen this patent in a different project. And so I can kind of just get an automatic reminder like, hey, you've actually seen this before. Maybe it was for a different project. It may or may not be relevant to this one, but at least I can take advantage of the work I've done in the past and AI analysis that I've done in the past without necessarily having to go reread the thing again and try to remember if it's something I've seen before or not. All right. I could, were there any other questions about that, or can I move on to this next bit before we get into?
I want to be respectful and make sure you can introduce Yasu, and
yeah,
we're really excited to hear the Japanese perspective because things are a little bit different, and I think there's a lot that some of us in other parts of the world can learn about the rigor that our Japanese colleagues bring to this sort of work and the respect that they bring to this work. And so I'm excited to hear what he has to say as well.
Yeah, totally agree. So I'm going to jump through this next section so we can get to Yasu. This is the last bit to share for Amplified is the accurate search kind of basic technology that we built around that actually helps us to build a better classifier. And that's what we've been working quite hard on is custom classifiers. And the AI kind of already knows something. You can see that from just looking at the search results. So we're not starting from scratch when we're doing a classifier, and you can kind of observe this if we put patents on a map where each dot is a patent and they kind of get grouped based on what's similar, and then we overlay CPC codes with colors, you can just see that naturally similar kind of technologies cluster together. So the AI kind of already has some sense of which patents belong together. And rather than start from scratch, we can just fine tune. So we can add some training data and we can fine tune this with a custom classifier. And so a little flashback to episode 3, where we talked about the gold standard case study. We did a comparison of what kind of most typical classifiers are done with like a support vector machine. That's its baseline on the left. We compared that using our model to fine tune, and we found that the fine tuning gives you higher quality results with less training data required. So that was exciting that we could get that done. That was a year ago. We've had some progress since then. We've been able to build some of these classifiers, put them in the wild, and get some customer feedback. And with training data, in some cases, we've had customers that have a lot of training data because in this example, it's a monitor. Every month, they review newly published patents. They mark some as relevant, some as not. And they've done that for years. So they have all of this data about what is relevant and not relevant for any given kind of business unit. And we were able to take that, train a custom classifier, and we're pretty thrilled to see 96 to 98% accuracy on the validation data set. We then gave that to them. They did it in the wild, and they, out of 2,037 examples, our classifier got 2,027 of them correct, 10 of them incorrect. So that was pretty exciting. Now, this particular customer is Japanese, so they have zero tolerance for ever missing anything. They want to make sure they don't miss any relevant documents. So they needed to review some things that were going to be correct, just so that they could make sure to pick up those 10 incorrect. And it ended up translating into a 70% reduction in cost for them, which is pretty significant. And with that, I'm going to turn it over to Yasu for him to share a little bit about how some of these Japanese companies use this technology.
Okay, so give me 1 second to make him the presenter. This only takes a second. And okay, now, so Yasu, you've now been made the presenter, and you can feel free to share your screen when you like.
Sure. Thanks, Tony. Did it work for?
Yep, we can see it.
Oh, yeah, thanks. Thank you, Tony. let me start from my section. Today I'd like to share some use cases by Japanese enterprises, which is kind of improvement of their entire workflow rather than just how to search with Amplified. It's having a huge impact on their daily practice to not only reduce the cost relevant to the patent practice, but also some improvement and kind of transformation of their old style labor-intensive workflow to a kind of data-driven style. Then today, as you know, there's a lot of different types of workflows in enterprise. Today, I want to focus on two of them. One is the prior search, which is a component of entire patent filing process. And the second one is the competitor monitoring to build the data asset to track the competitor activities for portfolio management. And then let's get started from the prior search part. Here's in this diagram, I just want to show you a kind of legacy protocol of the patent filing for a single invention. The problem with the current process for Japanese enterprises, the enterprise takes very long time. Typically, it's more than 1 month to decide whether to file a patent for the particular invention. So the typical workflow is initially the researcher write up his own invention disclosure and then input that by filling the form at the internal repository, and then IP department reviewed that disclosure. And then IP department requests a search to the analyst, and the analyst run a prior search and write a report. Then IP department receive the report and then share with the inventor, and then do some novelty check process, and also differentiation from some critical prior art, and then start drafting of the patent. It's quite long workflow. Then the entire process bears some problem. The first one is the search part has very high overhead and long time before novelty check. That is because not only the complexity of the patent search practice, but also the kind of limited resource of the research analyst. Then also the entire process move around different department like R&D, IP, and sometimes the external search firm or attorneys. So there's a high cost from managing several systems and resources. Then because the entire process popping around the several different systems, there's a loss of the link between the data and communication. Then because of the loss of the link between the data and communications, despite the high cost of the entire process, there's no reusable data generated by the process. It's very cost intensive, but kind of ad hoc expensive process. So how they change the entire process by introducing Amplified. The new workflow actually reduced the entire reduce the time cost of the entire process. The key concept here is the researchers can do patent search by themselves. In this workflow, they write up invention disclosure, and as some demonstrated earlier, the invention disclosure can be an input to the Amplifier to search patent. And then doing some simple keyword search, they can find easy critical prior art. Then also that search process is in real time. They can use such Amplified even in the kind of group discussion by engineers. And also some IP staff and attorney can join that meeting for identification and novelty check, where they use Amplify for the purpose of so-called live search, where IP staff and attorney facilitate researchers to find critical prior art and differentiation from the prior art by using Amplify and decipher the patent information for inventors. Then save entire discussion linked to the found prior art in Amplified. Then it's just 1 or 2 days of the process. And after that, IP department can review the entire discussion process and found critical prior art. And then IP department can run some supplementary search by themselves on Amplified, and then finally decision file or not. So fairly smart. So the entire process can be run in a single place. That means all data and communication is synchronized in real time. So there's no loss of information. Thanks to that integration of the entire process, the patent search and filing process generate a very valuable data set for future work. For example, such data set can be used to alert inventors the existence of the new publication that's similar to their own invention, where I describe that as the following alerts. And also sometimes researcher can come up with a new idea of the improvement of the original invention. When he writes up that invention disclosure, it is very highly possible to find a very similar set of the prior art. Then they need not to review the same patents again and again, because Amplified automatically fetch the past knowledge of the patent review. So that usage of the past search result help your patent reviews dramatically. So the entire process is get faster and faster as you accumulate the data from the prior search. Then the second example is the so-called competitor monitoring. That is a regular practice to check the new patent filings by your competitors. The problem of this process is the tight timeline and slow process to create the monthly monitoring reports. The bottleneck is coming from the screening of the large number of patents captured by the search string. So they need to do that they need to screen more than 1,000 or more patents every month, and then create some report for the business unit to identify critical patents, and then prepare some invalidation process. Then if they fail to complete the entire workflow within a given time window, there's a risk of not acting within a short period of time to take care of such critical patents. And also, there's no way to recognize some anomalies outside of the given patent set from the original search string. So say your competitors file a new patent about the alternative technologies. The original search string may not capture that technology well. So even if you do a very structured workflow for the competitor monitoring, you often fail to catch such anomaly patents. The solution to this problem is a kind of a semi-automated process. As some introduced, the amplifiers have a very strong, powerful classifiers to automate the classification and screening of the set of patents. You just see some known list, see the list of known patents to the system. You will get some classifiers, and using the classifiers, you can semi-automate the process of the screening. And then, thanks to that automated screening, you can have more time to add value for reporting, and then the business unit have more time for review. Then also, amplifier does not, amplifier data is not fixed by particular such string. Even amplifier always can have an access to entire database. You also can catch the anomaly from the classifier output. So these two examples are typical solution to the workflow improvements currently running at the mainly Japanese enterprise right now. The core paradigm shift behind the SHIN is that the patent data is a variable intelligence for all. So in particularly the amplified has users more than 100 or even more for single enterprise users. The usage of such scale of users give us a very huge number of annotations to the patent data. They can use that amount of annotations to make their own custom classifiers that achieve more than 90% accuracy and F scores. The combination of the user scalability, data scalability, and the training data scaling change the entire workflow from the labor intensive to data driven. That's a huge trend in the Japan market. That's all from my side. Is there any questions?
Well, I mean, that's a fascinating discussion, and what I most liked about what I saw there was just the. I've always thought that in the patent searching and analytics world, there was always too much emphasis on sort of standalone items. That, you know, for instance, here's a visualization, here is a picture, here is a data set, you know, and as these objects are removed from a system or they're presented, they lose the opportunity to be able to be further reflected on and to build a knowledge base. So they become individual pieces of evidence that begin to lose context. I've always thought that systems that can provide an institutional memory and provide an opportunity for a knowledge base to be created within an organization is going to be much more powerful. And it's an expression in the US, the gift that keeps on giving. It just, you continue to perpetuate and grow this knowledge base. And to hear that this is being implemented, this is not just theoretical. You know, this is a real Japanese company with lots of users and the number of annotations, greater than 25,000 annotations, enormous amount of interactivity. And so it's very impressive. And again, I think you're getting to the heart of why it is that this hybrid approach, for lack of a better term, but you know, the idea of the machine human interaction and the taking advantage of the best attributes and traits of the humans, in addition to the efficiencies and the comprehensiveness and the precision that you get from the machine, because the machine doesn't get tired after they've looked at their 500th record. It is really, really powerful. And gentlemen, I apologize. Our audience has been so great. We just had 99%, or excuse me, 95% of the people stayed on until I started talking, and then they've started to drop off now as we talk plus the hour. So maybe I'll just say that every time I talk, they leave. But thank you. This has been a great session. If you have a couple of closing comments, that would be great. But we are at the top of the hour, and our audience has been very, very it's been great. Thank you for your graciousness for staying with us, and you know, we really hope that you've enjoyed this discussion.
Yeah, thanks so much for hosting, Tony, and really excited to share some of these updates and have the opportunity. Thank you so much, everyone, for sticking with us and listening to the whole thing, as well as lots of great questions throughout. It's been definitely an interesting journey for us, and learning just a huge amount from working with these Japanese companies, as well as companies in the US and Europe. And I think, Tony, you kind of summarized it pretty well for us. Is there's a lot of talk about AI and machine learning, but it's really this knowledge management that I think is at the core of everything, and how we can have data, how we can take advantage of data and platforms to really, I think, enact huge change. And there's just so much opportunity to do more with patent information, to be more strategic. And that's been, kind of the driving force for why we started Amplified, and what we've been chasing after is making all of that possible. So I'm very excited that we've made some progress. We've hit some big milestones, and I guess all I have to say after that is that we're really just getting started. There's quite a lot more very soon on the horizon that I'm not able to talk about just yet, but we'll be excited to share in the near future, and hopefully in, I don't know what episode number it'll be, but whatever the next episode ends up being that we do with ML4Patents. So thank you, everyone, very much.
Yes, and thank you, everybody. There's a survey. Please take just a few minutes to answer a couple of the questions. And again, thank you so much for your time today, and to our panelists. And we'll see you next time. Bye now.
Thanks a lot.
Thank you.